Hi everyone. So I'm going to take a moment to go through the basic tests that you can do on a starting system. Now, I'm not doing it on a vehicle, obviously. I've got a diagram here. It's pretty cool. It's like an interactive animation. So I can go through basically each individual test to show you exactly what it is that you're doing, how to hook your meter up, what the readings mean, and so forth. So in this diagram, we have our battery right here. So it's a 12-volt system, okay, but fully charged battery, 14.1 volts. That's pretty high, actually. Probably just came off the charger. Now we have our negative cable right there. We have our positive cable. You can see we have a large positive cable going to our B terminal at the starter motor. So this would be a very large cable going directly to the B terminal, and this terminal is always live or 12 volts. So just be careful if you're ever working on a starter that you don't go and touch this connection and then touch the chassis ground, because you will melt your wrench in half, which is why first step to working on a starter motor, we need to disconnect the negative battery. Okay, so we have our B terminal right there. Now we have our solenoid and the big contacts. So this right here, this kind of plate, or it's a disc, are going to be big contacts that are, when the solenoid is activated, connects our B terminal through the solenoid contacts to our M terminal. And then current flows through the starter motor. In this case, it's showing a electromagnetic field, but nowadays it's permanent magnetic fields. But either way, a lot of current going through the starter motor, getting the starter motor to crank. Now, in order for the current to flow through our solenoid here, we need to move the solenoid to make contact, and we do that using the S terminal, and that's this blue wire. Now, the S terminal is still a fairly high current, but not nearly as high as our main starter B and M terminals. But we still need to put it through a relay. So our relay has our control coil right here, and that's terminals 86 and 85. And then we have our load side of the relay, which is terminals 30 and 87. Now, terminal 30 is going to be battery power. 87, if we follow it down, ends up at the S terminal. But to get this switch to close, we need to activate the control side of the relay, which in this case is coming from our ignition switch. Nowadays, everything's going to be controlled through a computer. So nowadays, this, instead of being directly controlled by the ignition switch, would be controlled by a computer. But basically, everything else would be the same. So if I click crank, you can see that we are now cranking, okay? The relay is energized, the switch is closed, current has flown or is flowing through the solenoid, specifically at this point, the hold-in windings of the solenoid. The solenoid has moved over, making contact right here, so that the B terminal is now in contact with the M terminal, and we have current flow through the motor and it is turning. Now you can see that we have our meter hooked up to the battery to see what voltage the battery gets pulled to. Now, they've given us a chart over here that says normal ranges with a certain temperature and what the battery should drop to. Ideally, we would want to see it around 10 volts. If it drops too low, that means our battery is bad or needs to be charged or potentially replaced. So remember, whenever we're doing starter testing, the first step to doing any electrical testing is to confirm your battery is okay. All right, so we've checked the battery. Battery is working okay. When we crank it, battery voltage drops, which is normal because the starter motor is drawing a lot of amperage. All right, so now it says voltage supply and drop. Now I'm going to click here, which says battery plus cable. Now, how the meter is hooked up right now is our positive lead is on the positive terminal of the battery, and the negative lead is on the B terminal of the starter. Right now, it shows 0 volts. When we crank it, whatever's displayed on the meter is going to represent what voltage is dropping along this cable and the connections. So we call that voltage drop. Now, in order to measure voltage drop, remember we need to have current flowing, right? If current isn't flowing, then our voltage drop will not be showing. So if I now click crank, whatever is reading on the meter represents voltage drop or a loss of voltage along the cable. There we go. So we are losing 0.21 volts from the battery positive connection all the way to our B terminal connection. And that's okay. All right. Again, this is a high current circuit, high or large amount of current flowing. We're going to have some voltage drop at these connections. If this said 4 volts, that would mean that we are losing 4 volts along this cable and that the motor would only be getting around 8 volts and therefore would crank very slowly or not crank at all. So 0.21 volts is okay. All right, now I stop cranking and it says 0 volts. Now again, whenever doing voltage drop, it's extremely important to remember that we need current flowing in order for the voltage drop to show. So if you just hook your meter up like this, see 0 volts, you might think, oh, there's no voltage drop, but we need it to be cranking in order to show the voltage drop. Now we can also go on our negative cable. So in this case, the red lead is on the starter body because our motor is grounded through the engine block. So we're just on the starter body here. And then the negative lead or the black lead is directly on the negative post. If you forget which way it goes, just remember the red lead goes to the most positive connection or whatever connection's closest to the positive terminal of the battery. In this case, the starter body is actually closer to the positive cable than obviously the negative terminal of the battery. So red is always to the most positive connection or the connection closest to the positive connection of the battery. Okay, so we see 0 volts. Does that mean that we have 0 voltage drop? No, because we need this to be cranking. So I'm going to click crank and we now have 0.21 volts. So is that okay? Yes. Again, if we saw, 3.5 volts, that would be too much. That means we are losing 3.5 volts along our negative connection. Now this is our negative cable going from the engine block to the chassis, and this is going from the chassis to our negative terminal of the battery. And remember, if we have a bunch of corrosion here at the post and this connection, then that could be where the voltage drop is. All right, so we've tested our main 2 cables, our battery cable going from the battery positive to our B terminal, and from the starter body to the negative connection at the battery. So let's check out at the solenoid. Now we can measure voltage drop across the solenoid. So we've got our red to the B terminal because it's closest to the battery positive, and the black lead to the M terminal. Now this is going to be measuring voltage drop through the connection or these contacts in the solenoid. These contacts get burnt out over time. It just happens. And that's why when a starter motor doesn't work, you go to start a vehicle and you hear the click, click, click of the solenoid activating, but the starter doesn't turn. That means that the solenoid control, right, the small blue and red wires in here, it means that those are working, but the contacts in the solenoid are burnt out or not making a good connection, which is why if you take a small hammer, and gently tap the solenoid with your hammer or a large wrench, all of a sudden the vehicle starts. That doesn't mean you just fixed it by tapping it. That just means that you've confirmed that it's a contact between the B and M terminals through the solenoid. All right, now it's reading 12 volts, and that's okay. Now that's because, well, we're on the red or the B positive terminal right here coming from the battery, and our black lead, even though it's on the M terminal, well, guess what? Through the motor, through all the windings and everything, we end up having a path to ground right here. So the reason why we have 12 volts is because we have an open circuit. But as soon as we close this circuit, we should have 12 volts coming through this contact and out. So what it should read is 0 volts when it's cranking. And 0 volts would mean we have 0 volt drop, which would be great. Now, we're probably not going to have an exactly perfect 0 volt drop. We're probably going to have a little bit of voltage drop through those contacts. So again, we need to have current flowing for our voltage drop to show. So let's click crank. Current's now flowing through the motor. The contact is made, and we have a 0.21 voltage drop. Now, if it showed 6.2 volts, that would mean we'd be losing 6.2 volts through these contacts. All right, so I'm going to turn that off there. I'm going to look at switch voltage. Now, this is not looking at voltage drop. This is checking to confirm that we're getting 12 volts to the solenoid itself. If we did not get 12 volts to the solenoid, what would that cause? If we didn't get 12 volts to this S terminal, that would mean that we wouldn't have any current flowing through our hold-in and pull-in windings, and the solenoid would not make that distinctive clunk noise, okay? Because the solenoid makes a pretty good thud or clunk noise when it activates. So if we had a concern where the solenoid was not activating, we can hook our meter up and go to the S terminal, and while cranking, we should see 12 volts. So let's click crank, and oh, I see 9.76 volts there. Interesting. What should we see? We should see our battery voltage around 12 volts. Well, actually, let's take a moment here and think about this. What was our battery voltage while cranking? 9.8 volts while cranking. So if that means the battery's getting pulled down or is going as low as 9.8 volts, our S terminal would be pretty low as well with this thing cranking. Ah, look at that, 9.76. So that's why that voltage is a little low, because our battery voltage is going quite low with the starter turning. Now, if there was a fault, let's just say that the starter motor was not turning when we went to activate it, this number would be close to whatever the battery voltage is when we turn the ignition switch to the on position. All right, so it should be around that 12 volts or whatever the battery voltage is when the crank is activated. If this read 3 volts, that means we would be losing around 9 volts before the S terminal. So that would be maybe at the relay itself is corroded internally, or the contacts here, maybe this fuse has corrosion and causing a voltage drop. Okay, so I'm going to turn that off. Let's go to relay contacts. Okay, so right now we're seeing 12 volts. When we go and crank it, we're going to see our voltage drop through those contacts. So click crank. Look at that, 0 volts. That's a really nice contact through that relay. Okay, so I'm going to stop cranking there. Now, it's going to now have us measure resistance. When we're measuring resistance, we're not going to be cranking this thing. So we've got it as for checking the hold-in coil resistance. You can see that the S terminal is disconnected because we don't want any current or any power to our circuit, because our meter to test resistance is sending out a small amount of voltage out our red lead, and then it's coming back through the black lead. And the meter is looking for a voltage loss, or seeing how much voltage is coming back, and then it basically does Ohm's law for us to calculate the amount of resistance. So right now we have the S terminal disconnected, and if you're checking resistance, it's actually a good idea just to disconnect your negative battery cable, because we just don't want any voltage or current anywhere on the circuit, because it will mess up our readings a lot and could cause us to misdiagnose. So we've got the red lead on the S terminal and the black lead on the chassis or on the body of the starter. So this is measuring our hold-in winding. And we've got 2.2 ohms resistance. Now, when we go to the pull-in winding, we don't go to the chassis or to the frame or the body of the starter. We go to the M terminal. And in this case, we have 1.5 ohms. Now these readings are sounding pretty good. The resistance value through these cables, even though it's a big, long winding of copper, the copper strands are quite thick, so the resistance is not very high. So for the hold-in winding, we go to the body of the starter because the blue lead, or the blue wire here, ends up from the S terminal and goes right to the body of the starter. Where for the pull-in, which is the red lead, or the red wire, sorry, wraps around the solenoid and it ends up going to the M terminal, and that's for the pull-in winding. So we can easily check for an open solenoid for either the pull-in or the hold-in by checking from the S terminal to the body of the starter and from the S terminal to the M terminal at the starter. Then the last thing that they have shown here is our relay coil testing. Now this resistance is actually going to be quite high generally. Should be around 80 or 60 to 80 ohms. In this case, they're showing 22.5 ohms resistance. So that is pretty low. This has a low resistance in this coil. Maybe it's shorted internally and you would need to replace it. And the last thing they've got us here is looking at current draw. Now, current draw is going to be quite high, and the larger the engine, the higher the current draw. So right now we're showing 140 amps, and that would be around like a 4-cylinder engine. 6-cylinder, 180 to 210. 8-cylinder could be as high as 250. Now, if it's a diesel, it's even higher because diesels have very high compression. So as mechanical resistance goes up, the current draw also goes up. Okay, so as mechanical resistance goes up, the current draw goes up, and that is normal. If this thing was cranking very slowly and the current draw, let's just say this engine was cranking pretty slow, you go and measure the current draw and it's reading 400 amps, and you can smell burning. What would cause that high of an amperage draw? Okay, it's still trying to crank, but it's cranking slowly, super high amperage draw. What could be causing that is high mechanical resistance, like this motor itself, our internal combustion engine, is seized, a bearing spun or something like that. Where if this thing was cranking very slowly, but was only drawing 90 amps, that would be an indication that we have high electrical resistance. And high electrical resistance could be caused by voltage drop in our cables or something like that. Okay, so doing this testing can give you a good inclination of what's wrong with the starter motor. Don't just go and throw a starter motor in because there might be more to it than what meets the eye. All right. So I hope this was helpful, and if you have any questions, send them my way.